All right, so for the final exam, you're allowed one sheet of notes, both sides. If you want to use your 4 index cards, you can just use the 4 index cards. That's completely fine. You should have your T table and Z table from the last test. You're allowed to bring those to the final exam as well. I will not provide you with another one for the final exam. So please make sure to bring those. I think you're allowed to use Desmos just like we've been using for all the rest of the class tests. So I think is there any questions on the general, what you need for the final, or we're good with that? Okay. All right, the final will be 7 questions. It's cumulative. But as I was saying, a lot of the stuff we've done over and over again. There's really, honestly, only one question that is something like that's the probability type one that we just haven't done as much. The rest of them are Z-score stuff and things like that, which we've been doing a ton. So I don't think it's going to be overly difficult for you to do. All right, so first question, talking about UC enrollment, and they gave you the enrollment of the schools. So the first thing I want you to do is calculate the population mean. So, and we're going to also have to do the standard deviation for this. So there will be a couple questions, or at least this question on the test, that you have to figure out the mean and the standard deviation. You are allowed to use the website to do that. So that's what we're going to do. So, all right, give me 1 second. I'm going to type the numbers in and then I'll switch over so you can see it. So the only thing you really have to figure out for this one is it a population or is it a sample? So in this problem here, since they're giving you all the campuses, this is a population. So when we do the calculator, make sure we have population checked for that. Calculate, so there's my standard deviation, and it also gives you your mean, so it doesn't both at the same time. Makes your life a little bit simpler. So in this case, my mean is 20 point, we had what, 1 place? So you always go 1 place more than what they've given you in the problem. So since this one gives you 1 place, we go 2. So we got 20.36 is my mean. And then the next question asks for your standard deviation. And we have 6.42. So if you were to mess this up and then click sample, you'll notice that the mean still is right, but your standard deviation is wrong. So that will change that. So just be careful and make sure you have the population selected for that one. All right, any questions with those, with finding mean and standard deviation? I think for the most part, that's pretty simple. I don't think most of you are gonna have trouble doing that, so. All right, question C says to obtain and interpret the Z-scores for the enrollment for Los Angeles and Riverside. So remember to find the Z-score. It is the mean of the question minus the mean over the standard deviation. So for LA, I've got 27.7 minus the mean, which was 20.36, divided by the 6.42. Now, when you're doing this question, if you happen to screw up the mean and the standard deviation on this, and then you do this calculation correct, you will get the majority of the points, but you'll lose a few. So, because again, in this question, I'm looking at, do you remember the Z-score formula and how to use it? So, So LA was 1.4. So this. So 1.4, 1.14 for LA. And then Riverside is going to be 18.6. And everything else stays the same. So I would just keep it there and just go back and change the 720 something there to the 18.06. Or 18.6, sorry, not 06. So we get negative 0.27. So those are your z-scores. So Riverside's pretty close to the mean, just a little bit below the mean. LA is significantly higher than the mean. It's more than one standard deviation, so that's going to be in the 85%. Yeah.
That what you want for the interpret?
Yeah, just like in your own words, explain what they are. So there's a wide variety of things I'm going to accept there. So it doesn't. I'm not looking for anything specific. I'm looking like this is the most important piece: is making sure you have the actual numbers correct. So, all right. That's question one. Yeah, I was gonna say I don't think that's overly complicated. All right. Any other questions on question one before we go on to question two? So question two is the probability one. All right. So the first thing we need to do for these is actually to go through and calculate out each of those probabilities. So remember, probability is just the frequency divided by the total. All right. So these are pretty straightforward. You're just going to take each of the frequencies and divide them by the total. Once you get those parts there, then we can actually go over and start figuring out the other pieces. All right. The first one we've got is 0.184. So remember, I always want one decimal place after the percent. So this would be the 18.4%. You can do it, you can write it either way. 0.184, 18.4%. So if you're going to leave it as a decimal, it's 3 decimal places. To change to a percent, you'd have that 1 decimal place. So then we get, this one's actually 16.0 or 0.160. Here's one. Here's 1/2. Which one was that? Yeah. Two. 217. And 0.128. Add all those up, it should come out to be 1 or 100, depending on which one you're using. It can be a little off because we're rounding. So if you're 100th off or 10th off or 1,000th off on the other sides, that's not that big of a deal. You should be drastically off. It should be like 0.999 or 0.1 or 1.001, for example. It should be like off by about that much. But those are our probabilities there. So that's the first part of this question, is finding those probabilities. The second part gives you 4 different events that are a combination of those. So you need to find the probability that those are going to happen. So actually, I'm going to do this. Yeah, that's why I was a little later than I'd like to be. All right, so we've got our. Try to make this so I can actually see it. You'll have it on the same page, so it won't be an issue. All right, so H is between 20 and 100. So we're going to add up all the ones from 20 to 100. So we got the 0.131, 0.102, 0.27, or 0.078, and then the 0.217. You could also do the other direction and say, well, okay, I could just subtract off the 3, but in this case, it's about the same either way. So I wouldn't worry about it. So we've got 1. So you got 528. And then I was less than 50K. So in this case, I'd probably do the 1 minus just because there are only 2 that I would subtract off. I get 0.655. Jay says less than 100K. So this one's, there's only one over 100K. So this one I would definitely do the 1 minus. And I get 0.872. And K says at least 50K. So that means 50K and above. So we're going to add the last 2. We get 0.345. Any questions with those? Okay. Duplicate this slide. So how I would do these questions over here. So the not J one's pretty simple. That's just going to be 1 minus whatever the J was. The ones where you have the combinations, I wouldn't look at these. I would go back to your original things and combine them and figure out what pieces you're going to add. Okay, because there's going to be overlapping and stuff like that. And when you're looking at these numbers, that includes that overlap, which might get you the wrong answer. So it's going to be easier probably for the last three to go right back to the original amounts. So the not J one's pretty simple. That's just going to be 1 minus the 0.872. So I would get the 0.128 for that one. Now we have H and I. So H says between 20 and 100K. And I says less than 50K. So it's and. That means it's got to be both of those. So if we're looking at that one, it says H is between 20 and 100. So H is that one, that one, that one, and that one. And I says less than 50K. So that's going to be this, that one, that one, that one, that one, and that one. So the only ones that overlap are those. Okay, does that make sense? Because remember, and's got to be in both of them. So we're going to add up those three numbers right there. So we got 131, 102, plus 0.078. We get 0.311. All right, any questions on I found HRI? All right. Next one's H or K. So we're going to do the exact same thing. Let's look at each one individually and figure out which ones match up. So H or K. So H is, again, between 20 and 100. K is at least 50K. So that's this one and this one. And since it says or, I'm including anything that's circled, not the overlap. So or is anything that's circled. So I'm going to add up all those that I've circled, or just subtract off the first two. And we get 0.656.
How did you get the 656?
So since it's or, I'm counting anything I've circled. So I'm adding up all the ones that I've circled. Now the next one says H and K. Since it uses the same ones that I've just circled, the and says the ones that are circled twice. So in this case, there's only one that is circled twice, and it's a 0.217. Because and means the overlap. All right. Any questions on the probability question? Okay. So it's really just remembering what the ands and the ors and those mean. The rest of them, I think, are pretty straightforward. Next question. All right. Based on the study, we're going to assume the time between pregnancies of African elephants for elephants have more than one calf is normally distributed with a mean of 4.01 and a standard deviation of 0.94 years. So we've got that information. They want to know between less than 2 years and then between 2, 3, and 5 years. So when we're looking at this, that's going to be my, so basically I'm looking for my Z-score. And then they want the percentages for that. So we're going to go back and look at our Z table to take that Z-score and turn it into a percent. So in this case, I'm going to do the 2 minus the 4.01 and then divided by the 0.94. So they gave me all that information, so I don't have to find that information. All right, so we're going to take back to the calculator and divide this. So minus. In this case, we get negative 2.14 as my Z-score. All right, remember you're going to be able to use your other one, so you should have that. So we're going to look up negative 2.14 on the Z table. 2.14. So as a percent, we get 0.01618 or 1.618%. Because it says less than 2 years, that's exactly what this table represents. It's from basically 0 and up. So this one is, and since we're looking at less, we can take that number as is. Yes.
You want this with 3 decimal points?
It's the table gives you the 3, so it's fine. If you round it a little bit, it's not a big deal, but the table actually gives it to you that way. So I just wrote the number that was on the table. And that's why I stopped at 2 decimal places for that, because the table uses the 2 decimal places to find the Z-score. So there's no need to go further than that. All right, now it says between 3 and 5 years. So again, we have to do the exact same thing. We're going to look for the Z-score for the 3 and the Z-score for the 5. So 3 was negative 1.07. And 5 is 1.05. Since it's looking at between those two, we're going to take the biggest one and subtract off the little one. That's going to get me the middle of it. Okay. So we'll look for the 1.05 first. And we get 0.85314. That's the 1.05. And then we have the 1.07. That's the negative one. So negative 1.07 is 0.14231. And then we subtract those two. That'll give us between it. But remember, the 1.0 or the 85 is all the way over. So if we're going to subtract off the beginning part, yes. Um, 5 minus 4.01 divided by 0.94. So you get 0.7108. So 71.08% is between it. Yes. Oh, sure. That's right. Oh. So any questions on those? Remember, the test is going to be very similar. Just again, I just changed some numbers. So you're going to do a very similar thing to those. Now, as you can see, it's constantly going back to the Z tables. That's why I was like, the one nice thing about stats and stuff like that is it builds on itself. So it's like we've used the Z table so much that at this point that should be pretty easy for you to be able to use them too. So, all right. Next question. Question 4. All right. So this is looking at sampling error. So this one kind of has you do a little bit of calculations, but it's more about do you remember what sampling error is and how it's used? What is sampling error? It's the difference between what you get when you do your sample as compared to what really actually happened. Okay. So if in reality the mean population, if the tax return in 2010 was $11,354 and their sample was $11,266, what was their actual error? Yeah, we just subtract those two, right? And the error was $88. If the IRS had sampled 400,000 returns instead of the 308,000, would the sampling error necessarily have been smaller? You would hope. So it should be smaller because the more you sample, the better it's going to be. What is the biggest thing you have to do to make sure all this stuff happens? Randomize. The information has to be randomized. Okay? So remember, if they pick 400,000 tax returns, but they pick them all from the Northeast, that's not going to lower the sample, right? So how can they do it? Make sure they choose more returns and make sure it's a truly randomized sample. Okay, so that's basically what they're looking for in this question. So it's not, it's you understanding what sample return is more than finding sample returns or sample errors. All right, and again, like I said, there's a lot of different ways that you can write the answer for this question. The only one that actually has a specific answer would be question B in this case, which is $88. The rest of them, it's just a matter of how would you explain sampling error. So this one gives you the actual table, but you don't really need it. So I'm just going to cut it out for the actual us doing the problem. All right, so 5, 6, and 7 actually are very related to the test you guys just took. We're doing confidence interval and hypothesis testing. So a couple things that I noticed on your test I will go over to make sure that you don't make those same mistakes. The biggest error that was made was the difference between one-tailed and two-tailed. That was the largest error. Like when you were picking your values on the actual Z table and finding your things, that was the number one mistake that was made in this test. Process and wise, most people did very well, but it was a matter of that error when you were trying to figure out which direction you were going. All right, so in this case, we're determining a 95% confidence interval for the mean of venture capital fiber optic businesses. So they gave me the standard deviation and they gave me the sum of the data. So they didn't give me the mean, but they gave me the sum. So I have a random sample of 18. So if I wanted to figure out my mean, I'm just going to take that and divide it by 18. So 11397 divided by 18. And we get 6.33 is my mean. So we want a 95% confidence interval. So that means this is a one-tailed or two-tailed, basically. Confidence intervals 2. Okay? So when we're looking at the table, we're not looking for 5%, we're looking for half of that. So when we're looking for this, we're looking for 0.025, not 5%. Now, I want to show you something that I don't think anybody actually realized. The t-table I gave you. What's at the very bottom of the t-table? Confidence level. It gave you the z-scores for your confidence levels. And those are based on the two-tail. Because if you look, let's look at 95%. If you go back up, two-tails, 0.05. Okay, so in this case, my confidence level for 95%, my z is 1.96. Okay, I don't think anybody actually realized that. The funny part about it is I didn't catch it really until I went to make the answer sheet. I'm like, oh, it's right there. I have to actually go look at the z table. Made my life a lot easier coming up with the answer sheet. So in this case, I've got the 1.96. You also, if you had actually written down anything, those are the numbers I gave you for those confidence levels. So, like I said, a lot of people I saw basically pull the number for 5%. So for this one, what I saw was, let's see, 0.05 would have been like the 1.645, things like that, when they were looking at getting those values in there. So just be careful and make sure you're picking the right z-scores and stuff like that for what you got. All right, so I got 1.96. So my confidence level, when I'm doing it, I'm basically just going to take my mean, the 6.33, and then plus or minus the 1.96 times the standard deviation divided by the square root of 18. In this case, my low end is 5.39. And my upper end is 7.27. So I'm 95% confident that the actual mean is somewhere between 5.39 and 7.27. Yes.
So just like the last test we did, if it doesn't say interpret, you want us to write that.
Yeah, just give me some little sentence so that I know what you actually understand what the numbers are. Yes. All right. That's fine. All right. So this one, the second thing that a couple people did make a mistake on was figuring out if it was the T table or the Z table. Remember, the difference is what standard deviation they gave you. If they gave you the population standard deviation, it's Z. If they gave you the sample standard deviation, it is T. And the last one, they said the population standard deviation, so that's why we did the Z. In this one, they're giving us the sample standard deviation. That's why we're going to use T. They actually say T in the problem. Again, we're looking for a 95% confidence interval for the, and we're using T for this one. So confidence interval is always two-tailed because we're looking at both directions. So we're going to look for our T for two-tailed 95%, or two-tailed 5%, I should say. Now, what is my degree of freedom for this one? My degree of freedom is 15. So T in this case, so I'm going to go down to 15. I get 2.131. So then we're going to do the 85.99 plus or minus 2.131 times 8.08 divided by the square root of 16. Remember, it's the full sample, not the degrees of freedom. So notice it's basically the same formula that you did for the last one. The only thing the difference is the T instead of the Z. So I get 81.69 to 90.29. So I'm 95% confident that the actual mean blood pressure for all children with diabetic was between 81.69 and 90.29. All right. Any questions on that one? Last one. All right. So this one is a hypothesis testing. So first thing we have to do for hypothesis testing is figure out my null hypothesis and my alternate hypothesis. So in this case, my null hypothesis is that the mean is 72. And they want to know, they're saying it's exceeding that. So it's going to be greater than 72. So now is this one or two-tailed? One-tailed. And it's greater than, so it's going to be somewhere over here. That's what I'm looking for. All right, so now we have to figure out, are we doing Z or T? This is population standard deviation, Z. Okay. So we're looking for Z, and we're looking for 5%, and we're looking for one-tailed. So want 5% right there, right? On the one-tailed. So my Z is 1.645. One-tailed, 5%, 1.645. Oh, I didn't actually. We'll try this again. There you go, one-tailed. Let me scroll down. 1.645. And since we're looking at the upper end, we take the positive version of that. So now I've got to find my Z of what they've gave me. So we're going to take the average that they had was 78.3. So 78.3 minus 72 divided by 11.2 divided by the square root of 29. In this case, we get 3.03, which is up here. So we're rejecting the null hypothesis. So the mean is higher than 72 beats per minute. That's final. Okay, how stressed are we about our final?
Not bad.